in this chapter alone, so there's a few elements that you guys need to pay more attention to, especially on pH calculation. You have to know how to calculate pH of strong acid, strong base, weak acid, and also pH of a buffer solution. After that, it's going to be partition coefficient and also solubility product. So these 4 elements is very important. These are the key 4 elements in this chapter, so please pay more attention to it, especially like dealing with questions with long calculation. So please go through the entire notes and go through more questions with calculation. So let's go. Yes! For your, where is my ding ding? Ionic Equilibria, where did we stop? Solubility product. Okay. Let us try one more. Okay, now we can proceed with solubility product. It's not too bad. All right, guys, open up your chapter 23. We still have about 12 minutes, 10 minutes basically. Let's move on to solubility product. Page 28, chapter 23. Let's go. In 1 minute. I'm going to start now. Chapter 23 can, no problem. All right, guys, right now, let's look at our solubility. A second. Suddenly feel like changing my mind. Let me pick one hard question for. Okay. Never mind, guys. Yeah, don't. I have 10 minutes. I want to discuss one question on buffer, since buffer is the hardest. Yeah, 10 minutes. Yeah. So, guys, can everyone flip to page 20? Page 20. Is it a buffer solution? Yeah, it's a buffer question. Good. Let's try some questions on buffer. Okay, so because again, a buffer question is very difficult. Okay, so just finger cross. Hopefully, buffer question don't come out in exam. If you get buffer question, good luck. Good luck. Because it's really difficult. Thing is 3 mark, right? But when I show you the working, right? Yeah, it could be a 6 mark. Just that they never put it 6 mark because they know 90% of the students are gonna plan the 6 mark question. Yeah. Trust me, it's about 90% of them. You can try it out. You can try it out. You can try now. I'll slowly discuss. If you want to try, just ignore what I'm saying now. Just do yourself. Okay. But if you want to listen, then you can listen now. Or else, yeah, I do not have enough time to give you guys the time to do it now. Okay, guys. Now, when chlorine dissolves in water, the following reaction occurs. Solution of chlorine are used for water purification. pH of the solution is near to 7 by the addition of a base. Chlorine is dissolved in water to produce 1,000 cm³ of a solution. Oh, wow, okay. So you need the volume, yeah, to calculate the concentration. Okay, and containing 0.17 mole of HClO and 0.17 of HCl. A buffer solution is then prepared by adding 0.2 mole of NaOH into the solution. NaOH reacts initially with HCl. Keyword initially with HCl. Okay, good. Okay, guys, calculate the pH of the buffer equation. Die. Don't even know where to start. Okay, if you don't know where to start, refer to my 3-step hack, 4-step hack, basically. So, guys, again, whenever you look at any question and you are stuck, do not know what to do, buffer equation first. Okay, construct a buffer equation. Guys, how to make a buffer again? To make a buffer, we need a weak acid, and it's okay, a salt, right? It's conjugate. Remember, weak acid and it's conjugate. So, guys, now please tell me, what are the weak acid that we have? We have HClO, HCl. Which one is our weak acid? HClO. Don't tell me HCl. You guys A2. Don't HCl me. Please. So, guys, I know my first step. Buffer equation. So, guys, buffer equation is going to be HClO dissociate to form ClO minus and a H plus, correct? Am I right? Good. Okay, first step done. Okay, I will show you how to do it. Okay, guys, again, refer to my step. Try to do it. Okay, you have a lot of buffer questions. Go and practice all the buffer questions using my step. I already make it very simple for you guys already. Next, construct KA equation. Can you guys construct a KA equation? Go, construct a KA now. Okay, at least if you do all this right, you might still get 1 mark out of 3. Not too bad. Despite not getting the answer, you can still get 1 mark out of 3 or 2 mark out of 3. Still happy. Okay, second, buffer equation. KA. So what's my KA equation again? ClO minus H plus HClO, correct? Okay, yeah. You still have your KA equation, not bad. Okay, then guys, second step done. What is my third step? Rise table. You see, right, guys? Again, rise table to find HA and A minus. Remember, rise table. So, guys, do you know the concentration of HClO and ClO minus? No, you do not. Okay, I mean, this is the mole initially, but when you plugging it into your Ka, this concentration must be at equilibrium. Remember that. Okay, so now we have to perform rise table. Third step, rise table. I put my third step here. Do I have enough time? I put it here then. I have enough space. Okay, so in order for you to do it, right, you have to read the equation first. Okay, they say a buffer solution is prepared by adding NaOH to this solution. And this solution itself, guys, imagine this. Solution itself have HCl and HClO, correct? Each standing at 0.17 mole, correct? Okay, guys, first, they say this amount is added. Just imagine I'm throwing 0.2 mole of NaOH in it. Initially reacts with HCl. So guys, now I want you guys to tell me what is the chemical equation. NaOH react with HCl first, right? What is formed? H2O and NaCl, right? Good. And guys, rise table it, go. Okay, go rise table it. Ratio is 1:1:1:1, correct? Initially, 0.2 mole of NaOH added into 0.17 mole of HCl. So your rise table always minus off your limiting. Ding, 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 ding. So at the end of the day, you still have how much? 0.03, right? Is that right? Do you have any HCl? Nope. Do you have any NaC? You still have 0.17, 0.17. But guys, is NaCl important? No, look at your Ka equation. There's no Cl minus. You don't even need to care. There's no H2. You don't even need to care. So these two basically nonsense. Don't care. Okay, guys. Now you still have NaOH remain, you know. So you see right now, you add NaOH, HCl is totally gone. What NaOH will react with again? HClO. So guys, before you move on, second rise table now. This time, right? Do it here. You can do it as NaOH remaining will react with HClO to form a NaHClO and a H2O, right? Rise table it again, go. So the ratio is 1, 1, 1, 1. 1, 1, 1, 1. What is the NaOH left? 0.03. Guys, don't put 0.2. That was the initially before reacting with HCl. HCl is still 0.1700. Correct. All right, guys, next. Change. Minus, minus, plus, plus. Correct. Finally, no more NaOH. HCl is at 0.14. NaHCl 0.03. Now, do you see that? HClO found. NaHClO is your HClO minus found. Understand? Then you can plug it in already. Clear? All right, guys. Now, you see, right? They say it's 1000 cm cube. It's just 1 dm cube. It's quite fun for you. Okay, so because you do not need to change the concentration because this is mole. For concentration, it's mole divided by dm cube, right? So it's divided by 1. It's basically the same value, right? Okay, so guys, what you need to do, you just have to sub this into your equation. I want you guys to do it as a homework. And the final answer should be 6.87, yeah. Okay, just plug it in and try it out. Like the change column, change column, very simple. Just minus everything away. Minus the smallest one away. Minus the smallest one away. Done. And follow the ratio. Okay. So buffer question, rise table. Buffer, rise table. Buffer, rise table. That's it. Not very difficult if you follow the trick. Okay, please. So that's it for the class today. Next week, we're going to wrap up this chapter. Okay. And I will see you guys tomorrow also. Yeah, tomorrow we are doing, what is it? Organic nitrogen compound. Okay, bye-bye. See ya and ciao.
Wait, the change is what? How?
The change, you just look for the limiting. This one is smaller, right? For example, this smaller, right? So we minus off. For example, this smaller, right? You minus off. Done.
Oh, so it's just okay. Okay, thank you.
No problem.
Which one was the answer?
Yes.
Well, what's the answer?
Sorry?
What's the answer?
6.87.
All right, thank you. Bye.
Get it? Get answer. Okay, bye-bye. See ya. Yes. Please like and subscribe. Please like and subscribe.